All right, today we're going to talk about domain and range. So domain is the set of all x values that are defined within a function. So basically it's any x value that doesn't make the function like undefined or imaginary or something like that. You can plug it in, you get out a regular real number. Okay, the range is a set of all y values that are matched up after substituting in the entire domain. So every time you put in an x, you get out a y. And the range is all the possible y values you can get after plugging in all the possible x's. So here's a mapping of a function, okay, from x to y. So our domain, again, is the set of all x values. So we're just going to write it in a brace like this, and you just list them out. So every x that has a arrow coming off of it is in our domain. So 1, 2, 3, 4. Just list those out over here. All right, and then the range are all the values that those x's are pointing to. Okay, so 1 points to 6, and 2 points to 8, 3 to 5, and 4 to 6. Now you notice here that there's been one y value that's listed here that's been left out. It's not pointed at all. So 7 is actually not a part of our range because there are no x values that produce that 7. So only 5, 6, and 8 will be a part of our range. So let's take a look at this with a more continuous function. Okay, so we have this kind of zigzag, all right, but it's continuous going from this point to this point. So when you're doing domain, you want to map the domain to all of the x values, so the x-axis. So I'm going to map this point down to the x-axis. All right, that's saying 1, 2, 3, 4, 5, 6, negative 7. And then we'll map this point up to the x-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, then just imagine you're going to scrunch this entire function down onto the x-axis. So there would be an open circle here, there would be an open circle here, and then everything in between would be shaded in. All right, so you just need to write out what this is. Okay, if we're using interval notation, you can go from negative 7 to positive 9. You want to use parentheses on that interval notation because parentheses go with the open circle. Okay, or you can write it in inequality notation. So you start with the negative 7, then we say that that's less than, not equal to, because again, open circle is x in the middle, and then that's less than 9 on the end. Okay, for range, we want to do pretty much the same thing, except we're going to map it to the y-axis instead of the x-axis. So I'm going to take this bottommost point here, we're going to map that over to the y-axis, negative 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this highest point maps over here, 1, 2, 3, 4, 5, 6. All right, and again, just imagine that you're scrunching that entire graph onto the y-axis. There would be an open circle here, there would be a closed circle here, and then that entire graph would be smashed on top of here, and it would shade that whole part in. Okay, whenever you're describing these ranges, always go from the smallest number to the biggest number. So for range, you want to start at the bottom of the graph, work your way up. Okay, and you notice on domain, we went from left to right. So this one, you'd go from negative 9. That's an open circle, so parentheses, and it goes up to positive 6. Okay, positive 6 is a closed circle, so that should get a square bracket in interval notation. Or we can go into inequality, and you go negative 9 is less than, make sure you use y for range, and then again, since it's a closed circle up here, less than or equal to 6. All right, let's take a look at a more traditional function. Okay, you probably recognize this as a parabola. This is a quadratic equation. Okay, and it should have arrows on the end here to show that it's going forever. So let's talk about domain first. So again, I want you to imagine that this graph is being smashed down so it's a straight line on the x-axis. Okay, so I'm going to take a look. This point's kind of right in the middle, so that point would be here. And then if I take this entire line and kind of smash it down here, it's going to keep on going. So it's like going to shade, 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 and then it just keeps on going forever. That's what that arrow means. Okay, then if you take this side of the graph and smash it down on the x-axis, same thing. It's going to shade, 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 and it's going to keep on going forever. So there are no numbers on the x-axis that are being left out here. So in interval notation, we say that that goes from negative infinity to positive infinity. In inequality notation, it's really just some words, all real numbers. All right, let's take a look at the range. Okay, so I want you to imagine we're smashing that entire graph down so it's just on top of the y-axis. So this one's going to kind of map over here. It's going to be a closed circle right there. And then the rest of the graph goes up from there, and it keeps on going up from there forever. That's what those arrows mean. So this graph, not all real numbers, because all of this bottom part of the y-axis is being left out. But everything from here up counts. So that number is -1. So we can say -1. It's a closed circle, so square bracket, going up to positive infinity. Or in inequality notation, you say x is greater than or equal to -1. All right, this one's a little bit tougher because we have some kind of breaks in between the graphs. All right, so let's see what we got here. So for domain, again, we're going to pretend like we're smashing down just the graph part. So the dotted lines don't really count. All right, just the solid curve parts. We're going to smash those down on top of the x-axis. Okay, again, these all have arrows on the end of them, like that, it's like this, and like this. All right, so if I smash this down, this is going to go basically from here. It doesn't actually ever touch here, so I'm going to put like an open circle right there, and then it just keeps going like this forever. All right, and then smash all this down, and it's basically going to go from here all the way over to here. Again, open circle there, because we never touch this line. These are asymptotes, remember? Graphs cannot touch or cross the asymptotes. And then smash this part of the graph down, and you get basically here on and over. All right, so in interval notation, it's a little complicated to write this in interval notation, but we'll do our best here. So start from -infinity, and then we go up to -1, 2, 3, 4, 5. And then that's not included, so you put a parentheses because it's an open circle. And then we put a U, because then we have to say what this set is. This goes from -5 to +2. So -5 to 2. Again, parentheses because it's an open circle. Then you put another U. And then we finally describe this third section that goes from 2 to infinity. So parentheses 2 to infinity. All right, that's the tough way to write it. The easy way to write it is you just say x cannot equal -5 or 2. And that implies that x can equal any other number. All right, the range works in a very similar fashion. Pretend we smash this all down onto the y-axis. So the only part of the y-axis that's being left out is right there. Smash that down and you go up from there to infinity. Smash this part in and you go down from there, down to -infinity. So this one goes from -infinity to 0 is the left out number. And then it goes from 0 up to +infinity. Again, you could go the easier route on this as well and say y cannot equal 0. All right, so what if we do if they just give us an equation and we don't have a graph to look at? All right, that's where your calculator comes in. So square root of x plus 4 minus 3. Okay, we can use our calculator to graph this. All right, so let's open up a graph here. All right, type in the square root of x plus 4 minus 3. Hit enter. There you've got a graph. It's kind of beneficial if you can see the grid lines. You can actually pull those up if they're not already up on yours. You can go to Windows Zoom. Actually, no, you go to View and Grid. And then I like the lined grid. All right, and that shows you where we're at here. So if we imagine our graph here, this goes up to -4. All right, and then it goes off to the right like this. So our domain goes from -4 to infinity. All right, so let's write that down. Domain from -4, it's included, so square bracket to infinity, or we can say x is greater than or equal to -4. All right, what about the range? Let's go back and take a look. All right, so remember we're smashing it down on the y-axis this time. So I come over here like this. That's at -3, and then it goes up. So it would shade up like this on the y-axis, and it would keep on going up. So -3 to infinity on that one. Again, included, because it's a closed circle, or y is greater than or equal to -3.